Okay gang, our last topic in our forces unit is upthrust. So we're just going to have a look at a very specific force that's caused when we are displacing water. So it's going to be fairly quick and easy, but it allows access to a lot of harder questions, which is why it's been added. It's one of the new things to the syllabus, so I do expect there is likely to be questions on it in the exams. So I guess we should start by answering the question of what is upthrust. Basically, when you put an object into water, it's going to displace a volume of that water that's equal to its own volume. And the force pushing it up from the water is going to be related to how much water it displaced. In fact, it's going to be related by the weight of the fluid it displaced. So the upward force that the object experiences is going to be equal to the mass of the water it displaces multiplied by gravity, so 9.81. In essence, the upward force would be equal to the downward force of the water that would have been occupying that space. So this is going to link into ideas about density quite a lot, because if I've got different fluids, they're going to have different densities, which is going to lead to us having different upthrusts for the same volume object in different liquids. So this is how it could be an interesting thing to look at. Okay, so we just get the equation here. Upthrust is equal to the mass of the fluid displaced multiplied by g, so 9.81 in this instance. Okay, so it should be pretty straightforward, really. It does lead us to Archimedes' principle, so Eureka and all that. Basically what it says is that the buoyant force on a submerged object is equal to the weight of the liquid displaced by the object. So it's just a statement of what we've just said about upthrust. This is one of those ones you're going to have to memorise, and you could be asked to regurgitate this in an exam, so just memorise it because it is easy marks when they ask you those defined ones. Basically what we're saying is that if the weight of the water displaced is less than the weight of the object will sink, because that upthrust will be smaller than the weight of the object, so it will sink slowly, most likely. Otherwise, the object floats, because the weight of the water displaced could be equal to the weight of the object. It's never going to be more than, because it would just push it up until the volume displaced means that the amount is the same as the weight going down, so you're never going to get more. So if you put it down and it bobs up, it's because the volume of water displaced had a larger weight than the amount of the object, than the weight of the object, so it just bounces up until only the right amount of water is displaced so it can float. And that is it. That is it for upthrust. Like I said, it's the way this appears in questions that can be a little bit more complicated. These are the kind of ones that are going to require a couple of stages to your thinking. So when it comes to questions to do with liquids, you need to think about upthrust, you need to think about volumes, and you need to think about densities as well. Okay, so we'll have a practice with this in class. Nice short video for you this week. Enjoy, it won't last, and I will see you in class. Remember, if you have any questions, just ask me when you see me.